Okay, we are back with the lesson. So now that hopefully you watched the intro, okay, so we're going to be doing the basics of a hypothesis test. And here's the definition. A hypothesis is a claim about a population that is true. So I'm just going to put something here. This is going to be assumed. Assumed is true. Doesn't necessarily mean it is true, it's just assumed. A hypothesis test is a procedure for testing the claim. Okay, so like I said before, the null hypothesis is always an HO with a colon, and it's either going to be a P for proportion or it'll be a mu. Okay, 8.1 is going to deal with both of them. Now, and it'll always be an equal. The alternative will always be an HA or H1. Your book usually uses H1. This will be also a P or a mu, but this will be a greater than, a less than, or a not equal to. So basically when I read problems, I'm trying to kind of figure out the direction that they gave me. And you'll see once you start doing a lot of examples. You kind of have to see a lot of these before you can kind of get it. Okay, so let's go ahead and start with this example right here. This little statement here is very important because the claim doesn't always have to be in the null. Like I said earlier in the other video, I could say, hey, I'm an 80% shooter. And that would be my null. And then the alternative would be, you would say, no way, you're not that good, you're less than it. Or you could come to me and say, there's no way. You're less than an 80% shooter. So the null still would be the same. And the alternative would still be the same. It's just like two ways to do it. This, I'm saying it, and this is what you're saying it. So if you make the claim that I'm less than an 80% shooter, then we set the null to be equal and the alternative to be less than. If I say I am an 80% shooter, then we set the null at 80 and then we set the alternative at less than. That's what these things are kind of saying. The original claim could be in the null, but it also could be it could also show up in your alternative. So you definitely have to get practice. All I could say is the null has to be an equal. This thing has to be an equal sign. Okay, because we have to have a baseline assumption to do the test. Sorry about that. That's the other video that I did. Okay. We have to have something to be true to run the test. And the reason why, because these are all done on normal curves. So if you said I'm worse than an 80, this has to be the baseline. So then when you take my sample, like I said in the other one, and I make 62%, we could find 62% on here. And 62% is probably like way over here. And you would say, wait a second, that doesn't make sense that you're an 80% shooter if you're making 62%. Because the chance that an 80% shooter gets 62 or even worse is so small. Therefore, we could reject the baseline assumption. That's why I changed the notes up there to say that it's not true, it's assumed to be true. Okay, so this is kind of how it looks like in an example. The claim is the mean weight is 124. So since it's a mean, we use mu, and this is that's your claim. That's also going to be your null. The null always has to be an equal. Now the alternative, for the alternative, we're looking for some sort of direction. Did they say something about We think it's more than that, less than that. We didn't get this, so your alternative is going to be a mu. It's not going to be equal to 124. Remember, this stuff is all done before the sample is even taken. Okay, so now the claim is that you're less than a 124. Okay, since the alternative always gets a less than, we put that down here. And we're going to keep the null 124. Okay, now the last one is greater. This is direction, greater. That's a greater than sign. So, greater than 124. And your null is that it's equal to 124. Okay. Some other important notes, that if the alternative is a not equal to, we call that a two-tailed test. We'll get into why that is later. If the alternative is a greater than, we call that a right-tailed test. If the alternative is a less than, we call that a left-tailed test. Okay, so if the alternative is a not equal to, two-tailed, right-tailed, left-tailed. Sometimes they call this two-sided, they'll call this one-sided. So spend some time learning that. Okay, now basically these hypothesis tests has 5 steps. That's how we do it. So the first step is set up your HO and your HA. And the second step is find the test statistic. So the test statistic is either going to be, let me just push this thing over a little bit. Oh, that doesn't work. There we go. The test statistic is either going to be a z-score or it's going to be a t-score, and it measures how many standard deviations the statistic is away from the null. So if we look at the basketball problem, the null, the p was 80. So this is your null. Let me make it look a little better. So the null hypothesis was p equal to 80. But the statistic is what I did when I took the shots. So I got a p hat of 0.62. This is what I actually did. This is what I said. This is the baseline assumption that you're assuming is true. Well, the test assumes is true. And this is what I did. So on a graph, it would look like this. Here's 0.8. This is 0.62. So in this case, it would be a z-score. So this is the test statistic, and Statcrunch is going to find that for us. Statcrunch, it's kind of like finding confidence intervals. You just do the same old route, but instead of hitting confidence interval, you hit hypothesis test. Okay, so the significance level is really determined in the industry, and we'll get into a lot of these things about these later in the notes, but we need to make a decision, and we're going to end up getting this thing called a p-value, which is step 3, by the way. This is step 3, which Statcrunch will provide. You need to compare this to this, and this is going to be given. This is basically a community standard that provides us a cutoff. So this is your null. And then you take a statistic. Now remember, this null is about the population. So when you take a statistic, if the statistic lands over here, if this is your p hat, this is your p-value. So if this is really small, we could reject this null. And we'll go over those rules later about when you reject the null. Because it says, we compare the p-value to this value and make a decision if we should reject or fail to reject the null hypothesis. So the p-value is our decision maker. Okay, so finding the test statistic. Finding the test statistic. Here's the steps to find the test statistic right here. Okay, it's very similar to what we did before. Any proportion is always prop stat. I'll just underline it. Now for means, you have to pay attention. Hey, what's going on with the standard deviation? They're always going to give you a standard deviation. You have to pay attention to it. Is it the population standard deviation, which is this guy? In that case, you would hit Z-stat. If sigma is unknown, we only have the sample standard deviation. S is the sample SD. Then you're going to use T-stat. T-stat. Okay, so that's going to be important. We'll do a few examples real quick. Okay, so the claim is a proportion of p's is equal to, see, they make this claim, and since it's equal, we'll put the claim here. It's a p because it's proportion. Equal 0.25. So that's definitely going to be our null. Okay. Now if you notice here, there's nothing about direction. They don't say anything about we think it's more than that, we think it's less than that. So that makes your alternative, which is 810 alternative, not equal to. Okay, so from before, from the notes we just did, if your alternative's a not equal to, that's a two-tailed test. And then this is a Z-stat. Proportions, well, I should be careful. You're going to run a prop stat. But prop stat's going to give you a Z score for the test statistic. So you're going to need practice. When you're good at it, you're kind of already good at it, but you're going to end up with a Z score. But this is what you're running in Statcrunch. Okay, let's do problem 2. The claim is that the professor normally distributed with the mean greater than 123. Okay, so means are mu's. So the claim here is mu is greater than 123. And whenever you do these, if they give you a claim that's a greater than, that's always going to go in your alternative. Even if it was a less than or not equal to, your null is always going to be equal. Now this is our baseline. It's like the guilty and innocent. You know, we always say somebody's innocent. It's up to them to provide that you're guilty. So if they want to say it's greater than 123, they need to find enough evidence that it's 123. So we're going to assume that it's not greater than 123 until there's evidence that comes forward that it is. Okay, a sample of 22 professors had a mean IQ of 125. Find the test statistic. Okay, so Z-stat or T-stat. So let's look. This is a mean. What means you have to be a little careful. Are we using this or are we using this? This is going to be Z-stat. This is T-stat. And I'll try to leave that up there for a little bit. And there's our standard deviation, so we should be using Z-stat. Okay. Okay, so we are back. And I have Statcrunch open. So, to solve this question, where are we at? 123. I'm trying to find the test statistic right here. Test statistic. So to find the test statistic, we have to run the test. I mean, there is a formula for it, but we would just rather run the test. So what we do is use stat. It's a Z-stat. It's one sample because I only took one group of 22 professors. Summary, because we don't have the actual scores. The mean is 125. Standard deviation 9. It's right here. Mean. Okay. Now this part needs to match this part. So this needs to be an equal 123. and I need to change this sign to a greater than, and that defaults there. And then we hit compute, and we're just looking for a z-score. Compute. So our test statistic, oops, it just disappeared. Our z-stat is 1.04. And that's step 2. This is step 1, which you'll see in 8.2 when we get to them. Okay, so let's look at the next one. It's essentially the same thing. It's a mean, so we're looking at this z-stat or t-stat, but here the standard deviation is 12, and this is from the sample. So since that's from the sample, we're going to do a t-stat. Okay? So let's see if it's the same thing, if it's still two-sided or one-sided. Oh, it's still greater. So they're just showing you the difference. This is a right-tailed. This is also a right tail, but this is going to be a t-stat. So I'll pull Statcrunch up again. And get out of this. I don't need any of this stuff. Okay, so let's go down to hit stat and then t-stat. Let's lower it a little bit so you can see. No. Okay, so we're doing this last one right down here, and you can see that the mean's 125, standard deviation is 12, same thing here. This is a t-stat, which I circled already. So let's go ahead and run the test. So stat, t-test. Okay, so once we're here, we go t-stat, one sample. Sorry, t-stat, one sample, t-stat, t-stat, one sample. We don't have the data, we have summary. So the mean was 125, I believe. Oh, I'm on the wrong one here. That's why it wasn't lining up. That's better. Okay, 125, standard deviation of 12. Notice how it says sample standard deviation. Kind of even tells you there. 22. Now this thing needs to match your null, which is one. I don't know, why do I have 123 there? It should be 125. Oh, greater than 123. Okay. This should be 123. And that's a greater than. You have to be careful you don't get confused with the what's being tested and what happened in your sample. Okay, so this is what's being tested. This is what happened in the sample. So the sample result was 2 more than what they thought. Well, was 2 more than this 123. That doesn't necessarily mean that the true mean's bigger, because it's only 2 ahead. That could have just been by random chance. Okay, so we're all set here and compute, and our t is 0.78. 0.782. So this is a t-stat, 0.782. Okay, this is good. We don't have, finding p-values. We do have to do that. We're not going to do that here. Okay, so the p-value, which is step 3, is calculated from these guys right here. And I can't remember, it was a little over 1. So, okay, so we'll go ahead and teach you how to do that. It's not bad. We've actually done this before. It's just you didn't realize what you were doing when you were doing it. Okay. Now, we've done all this in the past. We're not going to do critical values because it's just a different method. So we've done this in the past. Okay. So you might want to brush up on this. Even though I'm probably not going to ask it, it's still good to know. Now, finding the p-value is essentially just using our normal curves. So the p-value, the reason they call it a right and a left-tailed test, this is a left-tailed test. And the reason why is because this is the normal curve that we did in chapter 6. This is negative 1.26. If I draw a line to the left and I shade to the left, hence left-tailed test, that's the left-tailed, that's the p-value. So all we have to do is open up, we have to open up Statcrunch and then just go to our normal curve. So stat, go to our calculators, sorry, not normal curve, go to our normal calculator. Okay, it's already defaulted on 0 and 1. So I'm already at less than. So all I have to do is put in a negative 1.26. And compute. And that's it right there. So 0.104. Let's get off that. 0.104, and that's your graph right there. Okay, so right-tailed have DF and a T. So we could graph this thing. Let me give myself a little bit more room if I can. Now in this case, this is still 0, but these are T's now. These are T's, not Z's. So I'm at 1.32. Draw a line up. It's a right-tailed test, so I shade to the right. And then instead of going to the normal calculator, I'm going to go to the T calculator. So I have to use my mouse. I have a pen and then I have a mouse. So T. I just want to move it out of the way so you guys can see it. There's the T calculator, and then the T calculator says, hey, what's the DF? Which I forgot the DF. The DF is 18. So the DF will tell the calculator what T model to go to. Now notice, since this is the right side, this has to be a greater than. We've kind of done all this stuff in different aspects of the class. And 1.801 and compute 0.044. Okay, so let's do this one right here. Two-tailed test. This is where it gets a little tricky. Two-tailed test, but it's not too bad. So what a two-tailed test does is you have to take this T, which is somewhere over here, 1.801, draw a line up, shade to the right, and then since it's two-tailed, you have to come over here and do 1.801 and shade to the left. It's two tails. The calculator, we have a couple options. We could find the between. We could find this and do 1 minus it, or we could do this and then times it by 2, which that's what we're going to do. We're going to find the right tail and then times it by 2. So remember my DF. Okay, they don't give me a DF, But if n is 15, the df is 14. So the df is always one less than the sample size. So just the 14. Oh, they still have, it's the same one. Same one. So it's basically, but it's a different model. Boom. So it's this guy times 2. I'll just do 0.05. So this shade was 0.05. By default, since it's perfectly symmetric, this is 0.05. So together we get 0.10. Let's try another two-tailed. So these are z's. That's 0, and this is 1. Negative 2.36 is over here. So I drive up, shade this part right here, and I'm looking, is this two-tailed? Yep, this is two-tailed. So then I have to come over here to 2.36. And you only two-tailed is when your h1 is a not equal to. So I have to find this. So we could find either one. Let's find this one right here and times it by 2. It's a different calculator though, because this calculator is for normal, is the normal calculator. So these are the normal calculator. So I could round that, it's 0.009, but I could round that to 0.01. So this little section right here, that shade, is 0.01. So by default, that's 0.01. So 0.01 and 0.01 added together or multiplied by 2 is 0.02. Okay, this side we're not going to do. That side we're going to do. So this is going to be step 4. So once we get this p-value, to be honest with you, for the most part, 8.1 is going to make you do these p-values by hand, but 8.2, Statcrunch is going to give you the p-values. Okay, so for the most part, Statcrunch is going to give you p-value. So once you get the p-value, this is that significance level which will be given. You compare your p-value to alpha. If it's less than alpha, your initial assumption is rejected. If it's greater than alpha, then your original assumption is not rejected. Okay? You need to really study that. And there's a little saying that might help you. If the p is low, the null must go. If the p is high, the null will fly. So maybe practice that thing. That's going to be your step 4. So we got step 1 is going to be a null and an alternative. 2 is going to be your test statistic. 3 is going to be your p-value. And 4 is going to be your decision. And that's going to be your decision, whether you either reject or you fail to reject. This is your decisions right there. Okay, now I'm going to kind of write different ways to do it. If you reject H null, then we have sufficient evidence for H1, the alternative. If we fail to reject H null, then we have insufficient evidence for H1. Now H1 is going to be a big old sentence. You know, it's not going to be that quick. It's not going to say H1. It's going to tell you what H1 means. Okay, so that's it for 8.1. I'll make another one for 8.2 and try to make it a little faster. If you made it to the end, thanks a lot, and stay safe out there.